What's up, everyone? Welcome to another episode of AI Buzz. Thanks so much for tuning in. Today, we're going to talk about the top 4 technologies that you're going to want to know if you want to work in data. This is going to be a more general overview of the technologies. We're not going to go into specific packages so much, but we're going to talk about general tools that you'll need to know. I have to start with Python, obviously. Right now, it is absolutely the global leader in data. R is great, and I think it's a great language. There's a lot of really great aspects of it, like R Shiny, things like that. But in industry, I don't think it's really used in production level code all that often. It's largely thought of as an academic language, and it definitely encapsulates this idea. It makes simple things slightly more complicated than they need to be. Within Python, let's talk about environments. You're going to be working within Jupyter Notebook, Python Shell, or hacking around in .py files. So each of these offer specific advantages. Notebook, you're going to be able to isolate sections of code that you want to execute. This is really great for kind of proving out an idea and changing things really quickly while holding other things in memory so that you don't have to rerun the entire script. Python Shell is really great for work that you do not want to save, that you really need to just check in quickly, see if you have a certain package installed, things like that. And lastly, the .py files are going to be parts of larger code bases where you're going to have a lot of different interconnected models that you really are going to want a separate script for. So you have these 3 different places you can work within Python: the notebook, the shell, or .py files. Within Python, you're going to want to always use virtual environments. I cannot stress this enough. If you're trying to write production-ready code, use a virtual environment. To emphasize this point further, let's talk about what a virtual environment is. And at a really high level, it's going to be a container for all the things that you want to store within a particular session of coding. I can explain why we need to use virtual environments with one example. And that is, if we're designing an application, we're going to need packages for it. Especially with medium-sized applications, you can end up needing a lot of different packages that you have to import. If you're just testing this locally, or if you're working on this over a short time frame, this is probably not an issue because developers of those packages aren't going to have time to release a whole lot of things that'll break stuff. By using virtual environments, you're able to export all of your required packages with one simple command, and that is pip freeze. This is going to tell you all the packages that your code is using, and you're able to export them really easily. If you're working on a large code base, especially if you're working on something that needs to be production ready, this absolutely is required because all these dependencies, they all have their own development teams, and especially over longer time frames, just a matter of time before one of those packages gets an update that's going to break everything you've worked on. We've talked about a couple of different ways that you'll use Python, Notebook, Shell, .py files. We talked about virtual environments. Let's talk a little bit about actual Python packages. Depending on what you're doing within data, the packages you'll need will vary, but you're likely going to have some familiarity with pandas. This is going to allow you to do a lot of manipulations with data frames and transform and do some simple operations like that. In order to visualize data frames, Seaborn is a fantastic library. It has some very beautiful visualizations of simple graphs, much better than Matplotlib if you want aesthetically pleasing graphs. Within the data science realm, you're definitely going to want to be looking at sklearn. Be very familiar with that. It's very straightforward and simple to use. Beyond that, you might want to specialize in another package like PyTorch or Keras, maybe even XGBoost. Try to pick one and really get knowledgeable about that particular one because there's a lot of them and the different implementations of TensorFlow, and trying to be familiar with all of them just might not be worth it. So try to pick one and get really good at it. So that wraps up Python. It was kind of a long-winded explanation, but it's rightfully so. Python is definitely the most used tool in data today. For everything from ETL to machine learning to visualizing, if you're going into data, you'll need Python. All right, so let's move on to other tools that you'll need if you're going to be working in data. Next up is Git. This is almost as important as Python if you're working within data at a company. Typically, you'll be part of a team that's all working on the same code base, and you do not want multiple people to be altering the same code. So that's why version controlling is so important. Even if you're just a sole person working on a project, it can be really useful to become familiar with Git because it'll allow you to see how your project progresses over time, as well as develop a portfolio to be able to show interviewers. If you're going to pick a couple topics to learn about with Git, learn about how branches work, learn about how merging works and pull requests, and a couple of the best practices associated with it. Fortunately, Git has GitHub Desktop, which allows you to use the graphical user interface to kind of interact and use all those really powerful commands, but in a visual way. Okay, next up is SQL. You might not be thinking that SQL is too hard to learn or that you don't need to spend a whole lot of time on it, but I can guarantee you will need to use it at some point to pull in data sets to actually work with. Almost every company likely has some sort of old relational database that you're going to have to pull data from, and to do this, you're going to need some form of SQL. Beyond just the simple select statements, try to learn some more complexities of it, like grouping as well as partition keys. Okay, last up is going to be Docker. This fits in really well with the virtual environment talk that I was discussing earlier. It is extremely important to containerize all your code because you ideally would want to be able to transfer your exact environment over to someone else's PC so that they could work on it. Or if you're not transferring the code for someone else, you want to be able to deploy this to production and you want to have your local environment match that of the production environment. One really awesome thing about Docker too is that you can actually specify your architecture build of your image. This saved my butt recently because I was working with my M1 MacBook here and I wanted to specify precisely what architecture I wanted to build my Docker image for. So depending on what you want to build, you can actually specify all of those things. By putting lots of time into a Docker file, you can really specify everything about your environment so that it can be easily transferred to others. Okay, so those are the 4 main technologies, tools, packages that you're going to want to know if you're going into data. They are Python, they are Git, SQL, as well as Docker. These are definitely the top 4 you're going to want to know. If you had to pick one, go with Python. If you're able to delve a little deeper, these other 3 are really going to set you apart from your competition if you're going for interviews. That's about all I have for you today. Thank you so much for watching. If you liked the video, be sure to drop a like as well as a comment down below. Also, consider subscribing to the channel. I'm coming at you with new and different videos all the time. I have a lot of great ideas coming up. Can't wait to make them for you. Thanks so much for watching. Have a good day. Bye.